Hey there, math fans. Today in this video, we're going to be talking about Chapter 7, Probability Key Ideas. Those key ideas are, what is probability? How do we find probability? And what is experimental versus theoretical probability? So probability is the chance of something happening. So if there's a 20% probability that it's going to rain today, there's a 20% chance it's going to rain today. And that's as simple as probability is. It's just the chance of something happening. But how do we find that chance? Well, here's where it gets fun. Probability is always a number between 0 and 1. And we can show that on the number line. 0. We'll make it a little better. 1. And in between that, we have 0.5, which corresponds to 50%. Oh, importantly, if you do not know how to convert a rational number, so like 0.5, into a percent, then you need to go back to Chapter 6 and review the key ideas and lessons on Chapter 6 of Big Ideas. Also, Khan Academy and so forth have great videos on that. So, if there's a 20% chance it's going to rain today, we're going to be about here on the number line. 20% chance it's going to rain. Okay, what is the probability that you're going to have a math assignment this week? That's 100%. So right here, we got math assignment. And then what's the probability that all the plants in the world are going to turn purple tomorrow? Not very good. In fact, 0%. So, plants. Okay. So probability is always between 0% and 100%. And typically it is written as percents. So if we're doing rock, paper, scissors, you have 3 different things to choose from. Rock, paper, and scissors. So what's the probability you're going to choose? Scissors. 33%, 1 out of 3. Scissors. Okay. Or if you're flipping coins, what's the probability of you getting tails? Tails. Out of heads or tails, 1 out of 2 gives you 50%. So we can see that when we look at how to find probability, as simple as it is, most simplified words is part over a whole. A little bit more descriptive words for that is the desired outcome over your possible outcome. Okay, we'll use flipping coins as our example for this lesson. So our desired outcome is to get tails. That is one desired outcome. Okay, I'm only trying to get tails. The possible outcomes are I either get heads or tails. That's 2 possible outcomes, which gives me 1 over 2. Well, 1 divided by 2 is 0.5. That's a rational number. So to convert that into a percentage, we just multiply that by 100 or move the decimal place over twice. Again, if you are confused right now, you need to go back to Chapter 6 and review how to do this. But basically, when you turn a rational number into a percent, you times it by 100. When you turn a percent into a rational number, you just divide by 100. So you move the decimal place twice to the left or twice to the right, depending on which way you're going. Okay. So 50% of the time I flip a coin, I will get tails. That brings us to our last key point, theoretical probability versus experimental probability. In a perfect world, 50% of the time tails will come up on flipping a coin. So if I flipped a coin 4 times, 2 of them will be tails. If I flipped a coin 20 times, 10 of them will be tails. In a perfect world. You guys all know this is not a perfect world. And if I actually flipped a coin 20 times, I probably won't get 10. So I'm actually going to do that right now. I'll flip a coin 10 times. I'm going to ask Miss Hewitt and Mr. Rauer to also flip the coin 10 times, and we're going to show our data and compare that to the theoretical. All right, I just flipped this quarter 10 times, and I got 3 tails. Only 3. I was kind of disappointed in that, but whatever. So E for Egger got 3 out of 10. I texted Miss Hewitt. Miss Hewitt got 6 out of 10. And Mr. Rauer got 4 out of 10. All of us were trying to go for tails. So when we convert these numbers into percentages, 3 out of 10, 3 divided by 10 is 0.3 or 30%. Okay. 6 divided by 10 is 0.6 times 100 is 60%. And same math for Mr. Rauer, who wound up with 40%. Notice all of these numbers are our experimental data. So when we actually ran the experiment, actually did the trials in real life, none of us got the perfect answer. None of us got the theoretical answer. The difference between experimental and theoretical is when you actually do the experiment, you actually do these things in real life, is what the actual outcome is. Now, the reason why is actually kind of advanced. I don't want to confuse you guys, but I'll try to make it as simple as possible. And it comes down to sample size. Okay, so we only flipped the coin 10 times. That's a relatively small sample size. That's why we had such big variation in our experimental probability when you compare it to that theoretical probability. If I flip the coin 1 time, let's see what happens. It's heads. So in that experiment of flipping it 1 time with a sample size of 1, 0% of the time I got tails. Does that mean every time I flip a coin, 0% of the time I'm going to get tails? No. So my sample size of 1 is too small to get an accurate reading. The bigger the sample size, the more accurate the readings. If we each flip the coin 1,000 times, we would get closer to that 50% theoretical probability. If we flipped it 10,000 times, we'll get even closer. If we flipped it 1,000,000 times, we would be really close to that theoretical probability of 50%. Okay, so when you guys are doing trials and when people are doing real experiments, they're trying to get as big a sample size as possible so they can have the most accurate outcome possible. Okay, that's the difference between experimental and probability. Keep that in mind as you guys are doing your game activity this week.